In this week's laboratory meeting, you and your partner will do an activity together using a molecular model kit. The purpose of this activity is to give you an opportunity to do some hands-on learning with molecular shape and with identifying isomers. You will get the most out of this activity if you put effort into really seeing how 3D shapes are translated into two-dimensional paper, and if you practice finding isomers using systematic changes in structures. In Part A, first you will build a model of methane. Notice the shape of this model and use it to draw a wedge and dash structure of methane. Make sure you see the meaning of what you draw on the paper. If you spend a little time to really see how the structure you draw represents three-dimensional molecules, you'll have an easier time understanding the chemistry we are learning now and later in the semester. If you don't think you're seeing what you should, please ask your instructor or your TA for advice. In Part A, you will also build the slightly larger molecules, ethane and propane. Once again, practice translating your structure into a two-dimensional representation on paper using the wedge and dash convention. Look carefully at the shape of each atom, taking note of the number of bonded groups and lone pairs. In Part B, you will practice identifying isomers. Models can really help you understand why two isomers are actually different molecules, even though they have the same formula. You will build several isomers of hexane and chlorohexane. You can see from the molecular formulas that each is a linear alkane, just like methane, ethane, and propane. You'll be more likely to find all of the isomers that you're looking for if you use a systematic method for finding each isomer. Practice being systematic when you're finding isomers. In Part C, you'll work with a chloro-substituted cyclic alkane. You can tell that this is a cyclic alkane from its formula. Notice that there are two less hydrogens than there would be if this were a linear alkane. These missing hydrogens indicate that there is an unsaturation, and unsaturations mean that there are either rings or double bonds. In this case, we'll start with the cyclic structures and find their cyclic, structural, and stereoisomers. Then, you'll also find isomers of its linear form. In Part D, you'll take a closer look at the molecular shapes around other atoms, like nitrogen and oxygen, which have lone pairs of electrons. You will build models of methylamine and methanol. When there is a spot for a lone pair on an atom, you can choose to fill the spot if you wish to represent the lone pair, or you can just leave it empty. Sometimes an atom that has lone pairs, like oxygen, does not indicate the lone pair in the model kit, except that it has the correct bent shape. Take this red oxygen atom, for example. Notice that it is bent, but there's no empty hole that represents the lone pairs. You simply have to know that the lone pairs are there even though they're not shown. After each part of this activity, there are some questions that you can answer after you build each set of models. If you have questions, please ask your TA or your instructor for advice, and make sure you completely understand how to find molecular shapes and systematic methods for finding isomers. Mastery of these two things will really help you come exam day, both in lab and in lecture.